A horizontal cylindrical tank has cross-sectional area A of x equal 4 multiply 6x minus x squared meter square at the height x meters above the bottom when x is less than or equal to 3. Part A, we want to find the volume V between the heights A and B, and it is given by the integral of A to B, A of x dx, and we want to find the volume between the heights 2 meter and 3 meter. So in this case, all we do is we simply take the integral between 2 and 3, A of x, and A of x in this case is just the expression given here, which is 4 and 6x minus x squared. And you can use the power rule, right, to take the integral 2 to 3. This is 24x minus 4x squared, and you use the power rule. We add 1 to the exponent, divide by 2, so that it's 12x squared, and then divide by 3 when I add 1 to the exponent, and we evaluate this from 2 to 3, and that should be 12 multiplied to 3 square minus 4 over 3, and then we plug in 3 for anywhere we see the x, and then minus, and we plug in 2 for anywhere we see the x, and that should give me 104 per over 3. This is the volume, so this is the cubic meter. So this is part A. Now part B, suppose that now the oil is being pumped into the tank at the rate of 60 liters per minute. So we are given the fact that the rate of change of volume, because this is 60 liters per minute, is the rate of the volume is changing. So that is dV over dt equals 60 liter per minute. Now, you pay attention to this problem. We are using the meter, right? And this units here is in liters, and we all know that 1,000 liter is equal to 1 cubic meter. So you can convert this to liters by dividing by 1,000. So 60 divided by 1,000, that will be 0.06. 0.06 cubic meter over the mean, okay, per minute. So that is your dV dt, the rate of change of the volume. Now they ask you to use the chain rule to find how many meters per minute is the height of oil is in the tank changing, or dx dt, because x is the height, dx dt. What is the rate of change of the height with respect to the time t? All right. So in this case, we have dx dt equal dx dv multiply dv dt. We have dv dt already, which is this number right here. So now I would have to find what is my dx dv in this case. Now, if you remember from part A, right, we know that the volume from part A, we know the volume is equal to the integral of the cross-sectional area. So I can find the dv prime of x, or dv dx, okay, dv dx, which is the derivative of the integral, right? You take the derivative on both sides, and it will give you back, you undo the integral, so you get back a of x. So dv dx is just a of x. Therefore, if I want dx dv, I will just take the reciprocal of that, which is 1 over a of x. So that will come in here, right? dx dv. So now I should have my dx dv as 1 over a of x multiply dv dt. And I know that my a of x is the cross-sectional area, that is 4 6x minus x squared, and it has the unit of square meter. And we multiply to dv dt, which is right here, which is 0.06 meter cubic meter over minute. So if you cancel the square and the cube on the top, you should have only meter per minute unit only. And then you have 0.06 divided by 4 6x minus x squared. And you can simplify this, right? You can simplify this by divide 0.06 to 4. So 0.06 divided by 4 is 0.015 over 4. Sorry, we already divide by 4. So it's just over 6x minus x squared meter per minute. And that is the answer. 0.015 divided by 6x minus x squared, which is this answer right here, meter per minute. All right, that is part A and B. Now part C. How long does it take to fill the tank to 3 meters, starting from a fill level of 2 meters? So basically, you are looking. Let's imagine that this is the tank, right? Just imagine this is a tank. You are looking to fill from a level of 2 to 3. Okay, how long would it take you to fill that? And we all know that from part A, it says right here, between the heights 2 meter and 3 meter, we have the total volume of 104 over 3. So the volume is 104 over 3 from the height from 2 to 3. And the rate at which the volume is changing is 60 liter per minute, right? 60 meter per minute. Okay, and that is the dv dt. It is 0.06 cubic meter per minute. So we have the rate of change of volume. We have the volume. So we just have to divide them to get the timing, right? So we take 104 over 3. This is the total volume from 2 to 3 meters. Divide by 0.06 meter per minute. So that will cancel the cubic meter, and then you will get back the minute on the top. And then you basically take this, divide by this. So 104 over 3 divided by 0.06, which gives me 577.78 minutes. So it will take you about 578 minutes to fill the tank from 2 to 3 meters. And the rate of change of the volume is the constant, 0.06 cubic meters per minute. So 577.78.